So this is question 4 in the afternoon. And the first thing it just asks us to draw a slope field. So that's pretty simple. You just have to remember that you have to go with the flow. You can't cross over slope lines when you're drawing this. So this is going to look something like this. And when we start at this point, it's going to kind of go through that slope field, not crossing any points. So if I'm crossing points, I don't mean to. It's just kind of, it's hard to draw this thing. So this is worth 2 points, and you got 1 point for each slope field that you drew. To use Euler's method to solve this, remember we're approximating f of 1 and we're starting at f of 0 using 2 step sizes. So we started at 0.8, which is what we're given. Our step size is 0.5. And so to use Euler's method, the way we do is we start with our initial value. And then our second value we get by finding the previous the previous y, and adding that to the step size multiplied by the derivative evaluated at 0.8. So when y is 0, we get 1 times -2, so we get -2, which gives us -7, so -1, so this is 7. And we take our previous y value, which is 7, and we multiply by our step size times our derivative evaluated at 0.57. So since this has no x, it's only being driven by the y is 7, which is going to make that -7/8. So our answer is 7 minus 7/16. Which, if you are a stickler for you can leave your answer like that, and that answer is perfectly correct and will be accepted on the AP exam. But they wrote it as 105/16. But you can leave it like 7 minus 16 if you like. Okay, here they want us to write a second degree polynomial. So we have to remember that a Taylor polynomial second degree would be, and we're writing it at around t equals 0, and we're using it to approximate f of 1. So writing it at t equals 0 would be f of 0 plus f prime at 0 times x plus f double prime of 0, x squared over 2 factorial. Alrighty, we already know that f of 0 is 8. To find f prime of 0, when t is 0, we know that y is 8. So dy dt, when t equals 0, is going to be 8/8, 6 minus 8, which is -2, which we just did from our previous problem. So this is going to be 8 minus 2x. Finding the second derivative, we're actually going to have to take the derivative of this and evaluate it at 0. So taking the second derivative of this, let's rewrite it as, we can use product rule. I don't want to use product rule though. So I'm going to write this as 6/8, which is 3/4 y minus 1/8 y squared. Taking the derivative of this is 3/4, but I have to use implicit. So this is going to be 3/4 y prime minus 2/8 y prime. And now I have to evaluate that. So evaluating the second derivative, let me just write this. This is the second derivative. Would be 3/4. When t equals 0, we already know that y prime is equal to -2. 2/8, I'm going to change that to 1/4. When t equals 0, we know that y is 8 times y prime, which is -2. So let's see what we got here. We have -6/4 minus negative or plus 16 over 4. So negative 6/4 is 3/2 plus 4, right? So that is our next value. So that's, how would you add that? That would be 8 over 2, so 5/2 x squared over 2 factorial. And that would be the Taylor polynomial. And actually it should be 8 minus 2t because that's our variables. I'm not sure if the College Board would have taken off for that mistake, but you want to keep it in the same variables that you were given with. And yes, we could simplify that, but why do we want to do that? All right. Oh, and they want us to approximate f of 1. So to approximate f of 1, we would just evaluate this at 1. So this would be 8 minus 2 plus 5 times 1 all over 4. And that is 29/4. Okay? And that was worth 4 points. You got 1 point for finding the second derivative, so you got 1 point for that. You got 1 point for, you got 2 points for finding the second derivative. You got 1 point for writing the Taylor polynomial, and you got 1 point for the approximation. The last one required you to know that this was a logistic function. And because this is logistic, what is our carrying capacity? Our carrying capacity is 6. But the reason that this was strange is because we started at 0. We started at 8. But our carrying capacity from this logistic function, and it told you it was logistic, is 6. So that means that it started above its carrying capacity and then it began to decrease. So the range goes from 6 to 8. And that's the range because it's logistic. Okie dokie. That is number, I think that was number 4 from your free response afternoon.